Now here we have a question, and it's given that a steel ball is suspended from the ceiling of an accelerating carriage by means of two chords A and B. So yes, this carriage is actually accelerating with acceleration A. It's given in the question. Determine the acceleration A. We have to find out what acceleration A is if it will cause tension in A to be twice that in B. All right. So these two strings A and B, which are responsible for holding the ball, will have some tension in them. Here, they've given that what is the acceleration if tension in A is twice tension in B. Okay, let's start. Well, this is given, right? And how do we start? First of all, if the carriage is accelerating, then the ball which is inside the carriage will be accelerating with the carriage itself, right? Because it is attached to the carriage by means of two strings. Make sense? Okay. So the ball is accelerating with acceleration A as well. All right. Let's draw the free body diagram. Whenever we have to analyze forces on a body, what do? Free body diagram, right? So here as well, the ball has a mass M. It will have gravitational force vertically downwards G. We know that. So mg is one force. Another will be tension by string A and then tension by string B. Okay, TA and TB are these forces. And as you can see, tension is always a pulling force. So yes, here these are the forces, right? We have these angles given as well. The strings are making 60 degrees each with the horizontal. And that is why if this is the horizontal, let's take horizontal as X direction, vertical as Y direction, then I have angle 60 degrees each of these vectors as well. Okay. Now, one thing is given that the ball is accelerating with the carriage and the carriage has an acceleration of A in X direction. Okay. So the carriage has an acceleration of A in X direction, which means in Y direction, it has no acceleration at all, right? So in Y direction, forces must be balanced. All right. Now, here we have TA and TB making angles. So let's just take their components and then write two equations along two directions. We can work with that. TA's X component will be TA cos 60 degrees, right? Which is what? TA divided by 2, half TA. Let's write this over here. TA by 2. What about Y direction component? It will be TA sine 60 degrees, which is root 3 by 2. So I'm just going to write directly TA root 3 by 2. Similarly, when I take TB's components, again, the angle is the same. So I will get TB cos 60 degrees, which is TB by 2 over here. And TB sine 60 degrees, which is TB root 3 by 2 over here. Okay. Now I can say that vertical forces are balanced and horizontal forces, mass is net force is equal to mass into acceleration. We can say that, right? Okay. Here TA is given as 2 times TB, right? So what do I say? TA is 2 times TB. So this can be written as TB root 3 and this can be written as TB itself, right? Now let's write our equations. What do I say? Vertically downwards, we have only one force, which is mg. This should be equal to net force vertically upwards, which is how much? TB root 3 by 2 plus TB root 3. Okay, we get this much. Let's say this is equation number 1. What else can we get? Another equation for X direction, right? All right. So for X direction, I can say net external force is equal to mass into acceleration. And horizontal acceleration is in this direction. So of course, TB, TA by 2 is equal to TB, right? So TB minus TB by 2 is equal to mass into acceleration. Okay, this is equation number 2. Using these equations, I want acceleration's value, right? So using equation number 1, I can find TB's value and then substitute in equation number 2 and find acceleration's value, right? Let's do that. So here, well, I had an equation TB times root 3 by 2 plus TB times root 3. This is equal to mg. What does this give me? Yes, 3 by 2 root 3 TB is equal to mg. So TB comes out to be equal to 2 mg upon 3 root 3. Okay. TB we got. Now, using this, we can find out acceleration. We had TB minus TB by 2 is equal to mass into acceleration, right? I can see. TB minus TB by 2 is half TB only. So, I can say TB by 2 is equal to MA. Acceleration will be equal to how much? Substituting TB, 1 by 2m into TB, which is 2mg upon 3 root 3. 2 gets cancelled out, m gets cancelled out. I get acceleration value as g upon 3 root 3. Okay. G by 3 root 3 is the value of acceleration, for which one tension will be double the other's tension, right? Okay, let's go to the options. Quickly figure it out. Option number D is the correct answer. Now here we have 3 blocks given in the question, right? A, B and C. Weighing 1 kg, 8 kg and 27 kg respectively. Connected as shown in the figure with an inextensible string and are moving on smooth surface. Tension T3 is equal to 36 Newton given to us. So this tension 36 Newton is given to us and we have to find tension T2. T2 is tension in the string connecting B and C. Alright. What do? First things first, if we look at the whole thing, since A, B, C are connected by strings, if C has an acceleration, C is being pulled with 36 Newton. If C has an acceleration, all of them have equal acceleration, right? Because they are connected with these strings. So, I can say that, let's say, acceleration is A, and now if I make free body diagram of the whole system, A, B, C combined, I can say what? Net external force on the whole system in horizontal direction is only 36 Newton. That's it. Total mass we have, we can find out acceleration. We can say acceleration is equal to 36 upon total mass, which is how much? 27 plus 8 plus 1, which is 36. Yes. So 1 meter per second square is the acceleration. All right. Now, we want to find out tension in string 2, T2, right? And again, we want to make sure T2 appears in the free body diagram that we will draw now, right? In order to find T2. So, which free body diagram should I draw? For 8 kg or 27 kg? Because 1 kg is out of the picture. T2 is not acting on 1 kg, right? Okay. 8 kg or 27 kg, in this case, actually, I can draw free body diagram of 27 kgs because I want T2, but I do not know T1, right? So, I draw the free body diagram of 27 kgs. I will say horizontal forces, one is 36 Newton on this side and the other T2 on the other side. That's it. Had you drawn free body diagram of 8 kg block, you would have ended up with, see, T2 over here and T1 over here. And you do not know the value of T1 as well, right? You've just calculated acceleration. That's it. And so, I do not need to calculate T1. I just need to calculate T2. I will draw FBD of 27 kgs and say that acceleration is what? 1 meter per second square. Net external force is mass into acceleration. Only in horizontal direction we are analyzing right now. So, I will say 36 minus T2 is equal to mass into acceleration 27 into 1. Okay. See, acceleration is in this direction. So, net force in the direction of acceleration we have to write. Right? Okay. This T2 comes out to be 9 Newton. Okay. T2 is equal to 9 Newton. Let's go to the options. Option number B is correct here. Now here in this question, the acceleration time graph of a particle moving in a straight line is shown in the figure. Change in velocity of the particle from t equal to 0 to t equal to 6 seconds is. So 0 is here, 6 is here. For basically, in this whole interval, what is change in velocity? Now, we know a direct relation between change in velocity and AT graph, right? Yes. Delta V is area under AT graph. We just want to find area under AT graph. That will be change in velocity in here. Okay? Let's see. From 0 to 6 seconds, I have this as the positive area. Look at the graph, and this as the negative area, right? And we will add up these two areas with sign to get change in velocity. Delta V is equal to positive area of the upper triangle, which is what? Half into base into altitude minus area of the lower triangle, which is half into base into altitude. Okay, this gives me 8 minus 4, which is equal to 4 meter per second. Delta V is equal to 4 meter per second. Change in velocity. Let's go to the options. I can see option number B is the correct answer. Now here it is given that two bodies A and B are thrown simultaneously. This is the keyword here. Okay. A is projected vertically upwards with 80 meter per second speed from the ground, and B is projected vertically downwards from a height of 160 meter with 40 meter per second along the same line of motion. We have to find the time taken for the two bodies to collide. So here both the bodies are projected at the same time. So their motions are happening exactly simultaneously. And here I can stop one of them, use relative motion and solve the problem easily. No need to tackle two separate motions here, right? Okay. So we have two motions happening. Both are motion under gravity. One ball is thrown from up and other ball is thrown from down. So let's say this is ball A. Ball A is thrown up with an initial velocity of 80 meter per second like this. And ball B is thrown from the top of the tower. Let's say tower's height is h. H is given as 160 meters. B is thrown vertically downwards with an initial velocity of 40 meter per second. Alright. Now in here, both are one-dimensional motion under gravity. Both are, equally complicated or equally simple motions. So I'm just going to pick one and stop it. Okay. Generally, applying relative motion, I suggest you take the easier motion, less complicated motion and stop that one. It will always end with a smaller solution for you. Okay. All right. Here, I'm just going to stop A. Okay. So what is happening? If A remains here at this point, then how is motion of B relative to A? When will B collide with A? When B has reached position of A, right? Okay. So I can say displacement S of B relative to A that we want is equal to how much? Total height of the tower, which is 160 meter vertically downwards. Okay. This is the relative displacement. What about relative velocity? Initial velocity U relative B with respect to A can be calculated as UB minus UA, and I'm going to take vertically downwards as positive, upwards as negative, because most of the vectors that I have are vertically downwards. Alright. What do I get? Initial velocity of B with respect to A will be equal to 40 minus 80. This is equal to 120 meter per second. This also vertically downwards. Alright. What about acceleration though? Both have same acceleration g vector. So, relative acceleration will be g vector minus g vector equal to 0. Relative acceleration of any two bodies having motion under gravity, whether it is 1D or 2D or 3D. Motion under gravity, relative acceleration will be 0. Okay. So, B with respect to A is equal to 0. What does it look like then? The relative motion is uniform. So, S relative is equal to V relative into time. That's it. So, time we have to find out. Time will be equal to relative displacement, which is 160 meters divided by relative velocity, which is 120 meter per second. What do I get? I get 4 by 3 seconds. Let's go to the options. I can see 4 by 3 seconds, which is, in here it will be 1.33 seconds. Option number B is the correct answer. Now in this question, it's given that a car and a truck both move on the same straight line at the same instant of time from the same place. Alright, the car moves with a constant velocity of 40 meter per second and the truck starts with a constant acceleration of 4 meter per second square. That means initial velocity of the truck is 0, acceleration is uniform 4 meter per second square. Find the time that elapses before the truck catches up with the car. Okay, so here we have simultaneous motions going on of two particles, right? And whenever that happens, the easiest way to solve the problem is stop one of them. Okay, so we'll stop one of the vehicles. Now, in general, what I've seen is you get the shortest solution when you stop the motion which is uncomplicated, less complicated motion. Okay, so that way analysis is easier. Let's see. Here I have one motion is uniform motion and the other is uniformly accelerated motion. Which seems less complicated to you? The uniform motion, right? So I'm just going to stop it. Okay? Alright. So the uniform motion, car, I'm just going to stop the car. Okay? And what happens then? This is the car. This was the starting point for both of them. This is the car. It had a uniform velocity forward equal to 40 meter per second. The truck also started from the same point, right? So I'm just making it a little bit over here. Okay, so as not to overlap. The truck also started from the same point, but with initial velocity 0 and acceleration forward 4 meter per second square. Now, if I stop the car remains exactly here, right? And we want to find out the time when truck catches up with the car. That means the time when truck comes back to its original position with respect to the car, right? In the frame of reference of the car is right here. So what does the truck do? The truck goes away, comes back. Okay, this is what's happening in the frame of the car. So what is the initial relative velocity? Relative velocity, whenever you have to find out, we will always say velocity of truck with respect to car is equal to velocity of truck minus velocity of car, both with respect to ground. Okay, vector subtraction. So if I say forward direction is positive, backwards is negative, then I can always do vector subtraction, right? What do I get? Initial velocity of the truck is 0 minus velocity of the car is 40. So I get minus 40. What does minus 40 mean? It is in the reverse direction. Okay. So velocity of truck with respect to car is minus 40 meter per second. What about acceleration? Acceleration of truck with respect to car is equal to, yes, acceleration of truck minus acceleration of car, which is 4 minus 0, 4 meter per second square. Okay. This is relative velocity, initial velocity. This is relative acceleration. We want time when relative displacement is 0. Okay. All right. So what is the time when S relative truck with respect to car becomes 0? See, this relative motion is a uniformly accelerated motion. So I can directly apply S is equal to ut plus half at square. I can say in the forward direction positive, backward direction negative. I can say S is equal to ut plus half at square, where S, U and A are relative quantities, relative position, relative displacement, relative initial velocity and relative acceleration. Okay, let's apply with sign. S is equal to 0 is equal to ut minus 40t plus half 4t square. Okay, what does this come out? This gets cancelled out with 2 and I get t is equal to 20 seconds. Actually, it's a quadratic. I get two answers, t equal to 0 and t equal to 20 seconds. But I can easily say that relative displacement was 0 at t equal to 0 anyway, right? Yes, so that's an extraneous solution. We will not consider that. What do we want? When they again come at the same position, which is t equal to 20 seconds. All right. Let's go to the options. I can see option number B is correct answer.
For more videos and live lectures on the JEE, click on the subscribe button now.